Hello everyone. In this video, we are going to be going through this mathematics paper 1 from the DBE November 2023 exam. We are going to be doing and discussing these questions from this paper. So let us get straight into it. We have question 1.1, which is solve for x. So 1.1.1 is a straightforward one. We have a quadratic equation, x squared plus x minus 12 is equal to 0. This is already given in the standard form. So all that is expected from you is to simply solve for x here. Obviously, you can do that by either factorization, or you can also just write down the quadratic formula, substitute in the values of a, b, and c, and just punch all that into your calculator and get the answer. So this is very straightforward. And likewise, 1.1.2 is a similar question. However, here they say correct to 2 decimal places, which is always a clue for you that in this case, you cannot be able to solve for x by factorization. Instead, you must use the quadratic formula straight away. You shouldn't even waste your time in trying to factorize the expression. And all that you need to do here, of course, is to write this in the standard form. So you need to move 6 into the left hand side, and of course that will change its sign into a negative, so that you are only left with 0 on the right hand side, and then you just substitute into the quadratic formula. And then in 1.1.3, we have a square root of 2x plus 1 is equal to x minus 1. So here, the nice thing is that you see the terms that are under the square root are already isolated on one side of the equation. So this means that you can just easily square both sides of this equation, okay? Just like this, because this will of course remove that square root, and then you'll have to expand on the right hand side, right? And then from there on, you'll just have to bring all the terms to one side of the equation, add up all the like terms that you have, and after that solve for x. And you can either again do that by factorization if it is possible to factorize, but if you find factorization to be tricky or challenging, you can just simply use the quadratic formula. Now, what is important to note here is that after finding the two values of x, you mustn't leave the question like that or leave your answer like that. You must take your values of x and substitute them back to this equation. You must check in case one of your values of x are invalid for this equation. So you'll take those x values that you have obtained and substitute them back into this original equation. So for an example, if one of your x values, let's say maybe it is equal to -1, you are then going to substitute -1, so that would be 2 into -1 plus 1, and see whether what is this going to give you. If one of the values of x is -1, on the left hand side, because this is the left hand side, you are now going to have a square root of -1, which is a math error. So this means that if, for an example, one of the values of x that you had gotten was -1, that -1 would not be part of your solution, because as you can see on the left hand side, it's giving you a maths error. But I haven't done this calculation, so I'm not saying that one of the values of x that you will get is -1, but I'm just making an example to show you how to check if your answer, if your values of x are correct. So you must always check whether the left hand side is equal to the right hand side or not, So let's move on to the next question. All right, so now this one is an inequality. Now, I often notice that most learners usually find these quadratic inequality problems to be tricky, so I'll actually just do this one with you. So for 1.1.4, we have x squared minus 3 is greater than 2x. So here, what we need to do as usual, we must first start off by writing our quadratic expression in the standard form. So we must transpose 2x to the left hand side, which is going to give us negative 2x. And then we'll leave minus 3 there. And now we are only going to have 0 on the right hand side. Now, once you have your inequality in the standard form, you must work out the critical values. Critical values are the values of x where this quadratic expression is equal to 0. So you are now going to treat this as an equation instead of an inequality. You simply need to solve for x where this is equal to 0. And as you know, we can do that by factorization if it is possible. So what are the factors of x squared that we can multiply together to give us x squared? That is x and x. X multiplied by x gives us x squared. And now what are the two factors of 3 that we can multiply together to give us 3? That is obviously 3 and 1. 3 multiplied by 1 is 3. Now we need to consider the sign of 3 here. We see that it is negative. This means that the signs that are going to go into these brackets are going to be opposite. Okay? And we then go to the middle term. The middle term is negative. This means that the bigger number between these factors of 3 must have the negative sign. So 3 is going to take the negative sign and 1 will take a positive sign. So we have now successfully factorized our expression. This was an easy factorization. And now we can see that it means that the values of x are going to be x is equal to 3 or x is equal to negative 1 by simply equating what is inside each bracket to 0. So these are our critical values. And now what are we going to do with these critical values? We can use the number line method. So we just draw a simple number line there, and then along this number line we are going to write down our critical values. So first is going to be -1 and then 3. So these are our critical values. Like I said, critical values are the values where the equation is equal to 0. So that is why we must write zeros above these values. Okay? And now the next thing that we need to do, we need to determine the sign of x squared minus 2x minus 3 for values that are less than -1. Values that are in between -1 and 3, and also for values of x that are greater than 3. For an example, a value of x that is less than 1 is -2, for an example, but you can use any value as long as it is less than -1. So what we are going to do with this -2, we will substitute it into x squared minus 2x minus 3. So if we do that substitution, we'll have -2 squared minus 2 into -2 minus 3. So -2 squared is 4. -2 into 2 is also equal to 4, and then we subtract 3. So this is going to be equal to 5. But what is important the most about this value I've gotten here is that it is positive. It's a positive 5. So here we'll simply write a positive. And then we do the same thing now for a value that is between -1 and 3. So for an example, we can just simply use 0 there. So again, we'll substitute into our quadratic expression. So we'll have 0 squared minus 2 into 0 minus 3. I mean, obviously that will be equal to -3. So it's a negative value in this case. So we are going to write a negative there. And then we need to do the same thing for a value that is greater than 3. For an example, I can just say 4. And so even now we would have to substitute this 4 into our quadratic expression and see the sign of the value that we get, and that would be a positive value, whatever that value is, but it has to be positive if we are using a number that is greater than 3. How do I know that? Well, it's because this is a quadratic expression, right? And we know that the graph of a quadratic function can either be a smile or it can either be a frown. So if, for an example, these are our x-axis, here we would have the critical values, right? So likewise, if this is, for an example, the x-axis, here we would have our critical values. So if on the left hand side of the first critical value our graph is above the x-axis, it means that we have a positive there. So we see that the graph is positive, and then it is going to be negative in between the critical values, and then positive again. Likewise, if for an example it was a frown, you see that our graph on the left hand side of the first critical value is negative. It would then be positive in between these critical values. As you can see, it's above the x-axis, and then it would be negative again. So the pattern even on this number line is always like this. If you have a positive here, then you'll have a negative and a positive. But if here we had gotten a quadratic expression that gives us a negative here, then it would give us a positive here and then a negative there. It's always the same pattern like that. So anyway, that is what we get for this quadratic expression. And now, what does this mean for us? We need to go back to the problem. But we must focus now on our inequality that we had written in the standard form. So we want to find the values of x where our quadratic expression here is greater than 0. Greater than 0 means positive, right? So we're interested in the values of x that give us positive values in this quadratic expression. And this is clearly indicated by our number line. We can see that if x is less than -1, we get a positive value, or if x is greater than 3, we get a positive. So this is the solution for this problem. And as you already know, alternatively, you can also write this in the set notation. So you can say, for an example, x is an element from -infinity to 1 union from 3 to positive infinity. And we are using the rounded brackets because -1 and 3 are not included in the solution, or in other words, there is no n or equal to symbol in this inequality, right? And for infinity, we always use the rounded brackets. So that's how you can answer questions like 1.1.4. And then we move on to 1.2, which is a solve for x and y simultaneously problem. Well, this is but I think one thing that would probably intimidate learners with this question is the fact that we have the x and y in the denominator in the second equation here. But I mean, we can manipulate this and remove these x and y values from the denominator by following the rules of algebra. So as you can see, the first equation is relatively straightforward. In fact, in this equation, which is x plus 2 is equal to 2y, you can just take the 2 to the right hand side, right? And this would give us x is equal to 2y minus 2. Okay, so maybe let's call that our equation number 1. Now this is something that you can be able to work with. You can simply substitute this to the second equation that you are going to get. But as I was saying, it would be wise to manipulate this equation a little bit so that we do not have the x and y in the denominator. And one thing that you should note is that the fact that we have x and y in the denominator simply means that x cannot be equal to 0 and y it can also not be equal to 0 in this problem, because if that is the case, then this would be a math error. Anyway, what we can do here is we can just simply multiply these terms by xy. So I'm gonna multiply 1 over x by xy, and I'm also going to multiply 1 over y by xy. But then this is an equation, of course, so we must also do that on the right hand side. So we must also multiply by xy here. So we are simply multiplying by xy throughout. So this xy, as you can see, is basically a lowest common denominator for these two terms. But now the nice thing is that this x can cancel with this x and this y can cancel with this y, meaning that we are going to be left here with 1 multiplied by y, which is y, and 1 multiplied by x, which is x, and then on the right hand side we are going to have xy. Now you can already just leave this as your equation 2, and of course the next thing that you can do now, you can substitute equation 1 into equation 2. All right, and from there on you would be able to solve for x and y. Okay, so I'll leave the rest of it for you to do. You can let me know in the comments if you have any challenges with doing that. Now let's talk about 1.3. Here we are given now this is actually quite an interesting question. So we have 2 to the power of m plus 1 plus 2 to the power of m is equal to 3 to the power of n plus 2 minus 3 to the power of n, where m and n are integers and they want us to determine the value of m plus n. So how can we do that? Well, you must note here that I mean, we've got exponents, so you just need to know your laws of exponents here. So firstly, let's just take down the equation as it is. Okay, so first things first, if we look into the first term, we have 2 to the power of m plus 1. Remember the product law of exponents. If we use that law here, it means that we can write this term as 2 to the power of m multiplied by 2 to the power of 1. Because in multiplication, if the bases are the same, we add the exponents. So that's how we can write this as 2 to the power of m plus 1 by simply adding up the exponents and keeping the same base, because we have the same base here. And then there's nothing we can do with this one. We can just take it down as 2 to the power of m, and then again the product law of exponents here. So we can write this as 3 to the power of n multiplied by 3 to the power of 2. And again, if we wanted to rewrite this with the same base, we simply take the same base and then we add up the exponents. And then we have minus 3 to the power of n. And now from here on, you can see on the left hand side, we've got a common factor here, which is 2 to the power of m. So we can take that out. And if we then divide by this common factor, we are going to be left with 2 to the power of 1, which we can just simply write as 2. And then 2 to the power of m divided by 2 to the power of m is simply equal to 1. So we have just simply factorized by taking out a common factor. And likewise here we can also factorize by taking out a common factor, which is 3 to the power of n, and that is gonna leave us with 3 to the power of 2. So 3 to the power of 2, and then 3 to the power of n divided by 3 to the power of n is gonna leave us with 1. All right. And so what is the next step? We can sum up these numbers that we have in our brackets. So 2 plus 1 is 3. And then 3 squared, what is 3 squared? 3 multiplied by 3 is 1. Minus 1, that is equal to 8. So we are going to be left with 8 there. And now what can we do from here on? Well, let us isolate these exponential numbers on one side of the equation and also isolate these coefficients into one side of the equation. So how can we do that? Well, we can divide by 3 to the power of n on both sides of the equation, and also divide by 3 on both sides of the equation. What is this going to do? This is going to eliminate 3 on this side, and this will eliminate 3 to the power of n on that side, meaning that we are only left with 2 to the power of m over 3 to the power of n is equal to 8 over 3. And now, since the left hand side is equal to the right hand side, it means that the numerator of the left hand side must be equal to the numerator of the right hand side. So 2 to the power of m must be equal to 8. And at the same time, it also means that 3 to the power of n must be equal to 3. All right. And now here we can simply write this 8 with the same base of 2. And that would be 2 to the power of 3, meaning that m is equal to 1. And here it's straightforward. We already have the same bases, so it means that n must be equal to 1 because our exponent is 1 there. And remember that the question was determine the value of m plus n. So to finish this problem, we simply need to add m plus n. So this is going to be equal to, oops, why did I write 1 here? The answer is of course equal to 3. The bases are the same, so m is equal to 3. So this is going to be equal to 3 plus 1, meaning that m plus n is equal to 4, which is the final answer to this problem. So that is it, guys, for this question. I hope that, of course, you'd be able to do 1.1.1, 1.1.2, 1.1.3 yourselves, and that with the guidance I have given you in 1.2, you would be able to continue with the problem as well. I hope you have found this tutorial video helpful. If you have, please do let me know by commenting below. But also, if you have got any question, please also do let me know by commenting below. And don't forget to like the video and subscribe to the channel if you would like more videos like this one. See you on the next one.